The last topic we're going to look at in this section is the issue of when two graphs are called isomorphic. So first we're going to sort of look what it means for two graphs to be essentially the same as graphs. And then we're going to find a way of using that notion of graphs being the same to define what it means for graphs to be isomorphic and what an isomorphism is that tells us when graphs are isomorphic. So I'm going to look at two graphs. Here they are. And the way they're drawn right now, they look like very different graphs. However, if we rearrange the vertices of the second graph, we get the following. So all we did was we took the top two vertices, we moved that W3 to the left, and we moved W1 to the right. And otherwise, it's the same graph. It has the same vertices, the same edges as the original graph. However, the way we've drawn it now, it looks exactly like the graph on the left, the graph with the V1, V2, V3, and V4. So, and indeed, you could say that W3 plays the same role as V1. They're in the same spot in the graph. W1 plays the same role as V2. W2 plays the same role as V3, and then W4 plays the same role as V4. And we can actually summarize this identification, this who plays the same role as whom, by a function. So the function, I'm going to call it phi, just to be fancy. It goes from the vertices in V1 to the vertices in the second graph. And we get phi of V1 is equal to W3 because they play the same role. Phi of V2 equals W1 because they play the same role. Phi of 3 equals W2 and phi equals W4 because they play the same roles. And actually, if we look carefully at this, this has some interesting edge properties, right? So it was a function among the vertices that play the same role, but they also have something interesting going on with the edges. So notice that if you look at V1, V2, that is an edge in the first graph. And if you look at phi of V1, phi of V2, well, that's W3, W1, that is an edge in the second graph. So if and similarly, if you look at phi of V, or if you look at V3, V4, that is an edge in the first graph. And if you look at phi of V3, phi of V4, that gives you W2, W4, which gives you an edge in the second graph. And notice that both of those edges are in the same place in the drawing of the graph as the as where they came from. So the edges with the V's and the edges with the W's are in the exact same place. And in general, if you have an edge UV in E1, that is going to be an edge precisely when phi of U, phi of V is an edge in V2. And you can check that on the other two edges if you don't believe me. So now we're thinking about what properties should graph isomorphisms have. And isomorphism, I haven't told you what that word is yet, but really the isomorphism is that function phi we had before that matches up vertices in two graphs that are essentially the same, where the vertices play the same role in that graph. So the function should let us know that all the vertices in each graph are matched up perfectly. So all the vertices in the first graph should match up perfectly with the second graph. And the only way that can happen is if the function is injective and surjective. If the function is not injective, we'll have one vertex in the second graph playing the same role as two vertices in the first graph. And if it's not surjective, there may be a vertex in the second graph that doesn't play any role at all for any of the vertices in the first graph. The function should let us know that all the edges in the graph should match up perfectly. So in other words, if I have, if I look at phi of U, phi of V, that should be an edge precisely when UV is an edge. So if I have UV an edge in the first graph, phi of U, phi of V should be an edge in the second graph, and vice versa. So here is going to be our technical, precise, mathematically precise definition of what a graph isomorphism is. So you have two graphs, G1, G2, with vertex set V1 and V2, and vertex set, edge sets E1 and E2. An isomorphism between G1 and G2 is a function between the two vertex sets. So it goes from V1, which is the vertex set of G1, to V2, which is the vertex set of G2. That satisfies the following properties, three properties. First of all, phi has to be one-to-one and onto, because that guarantees that we have the same number of vertices in each graph. Whenever UV is an edge in E1, then phi of V should be an edge in E2. If phi of U and phi of V are playing the same role as U and V in E1, then they should have the same edge structure. And then third, all the edges of E2 should be of the form phi of U, phi of V. There shouldn't be any edges of E2 that do not come from the original graph. And we say that two graphs are isomorphic when there is an isomorphism between them. Now, I'll confess, I gave you this precise definition because I think it's important to give you the definitions. We're not going to get to the point where we're actually using this technical definitions on huge generalized graphs. But one of the things I do want you to do is recognize when two graphs are isomorphic and what the isomorphism is between those based upon what roles the vertices are playing in each graph. So we're mostly going to be using our model for understanding isomorphisms. And I call it the graph redrawing model. And this is just the same model we used informally at the very beginning of this video. So we say that two graphs are isomorphic if we can draw them both in such a way that they look identical. And when I say redraw them both, we maintain the same vertices and edges. We just draw the vertices and edges in different places. The isomorphism tells us how to draw the graphs so that they look the same. So they tell us which vertices play the same roles in both graphs. If we put those vertices in the same place relative to the other vertices in the graph, then the graph should look exactly the same. So if phi is the isomorphism between the first graph and the second graph, that when we draw the vertices v and phi of v in the same place, that will make the graphs look identical. All right, so now that you have this introduction to isomorphic graphs and isomorphisms between those graphs, now you're ready to work on the PDF file called Graph Isomorphisms, and that is included with this video.